This video is about multivariable calculus. In particular, it's the first video that I plan to make out of a series of videos on multivariable calculus, and it will be a more theoretical series of videos than probably most multivariable calculus courses. So depending on the demographic of the students taking it, oftentimes the multivariable calculus course that's offered at the university is fairly basic, so they don't assume that the students know linear algebra, and because of that you can't really get into the heart of multivariable calculus. You have to somehow make it accessible to students who are not very comfortable with linear algebra, and because of that a lot of the theory has to be swept under the rug, and those courses tend to be focused more on computations. So some books along those lines would be the books by Stewart and books like that. So just an overview of some books on multivariable calculus. So there's the book by Stewart. So there's a whole, it's a giant calculus book, but it's also broken up into several smaller volumes, and there's one volume on multivariable calculus. And there's also a book by Briggs, there's a book by Larson. So these books tend to not assume, they don't assume linear algebra, and so these are basically aimed at students who are engineering majors or computer science majors who may not know linear algebra or who might take it later, and so they want to take a course where they don't have to take linear algebra first before they can take multivariable calculus. And so those books are written mainly for those students, and they're not bad books to get an overview of the topics. Then there are books that require some linear algebra. I guess technically they don't, but you can kind of tell that it's written at a more theoretical level, and you can kind of tell that they pretty much assume that you know some linear algebra. So these are the books by Colley. There's a book by Colley called Vector Calculus, and there's a book by Marsden and Tromba. I forgot what it's called. It's like calculus of several variables or something. Let me look it up. Marsden and Tromba. Vector. Oh, they're both called Vector Calculus. Okay. And these books are actually pretty similar. So when I took multivariable calculus, the book that was used was the book by Colley. Now it's Colley and someone else. There's a 5th edition. When I took multivariable calculus, it was the 3rd edition. Now it's the 5th edition, Colley and Canez, I think that's how you say it. Canez? Okay. Well, anyway, I'm not a huge fan of the Colley book, to be honest. I like the book by Marsden and Tromba, though. I think it's a good book. Those two books are very similar. And these books tend to talk more about Rn and Rm. So these Stewart and Briggs and Larson books tends to just restrict to R2 and R3, whereas the Colley and Marsden and Tromba books talk about Rn in general. So it's more abstract. It's probably more suitable for an honors multivariable calculus course. And then there are these very old school books that talk about manifolds. So there is a book by Edwards. These books often go by the name Advanced Calculus. So there's the book by Edwards. It's a Dover book. There's a book by Buck. And there's a book by, what's the name? Spivak, Calculus on Manifolds, and a book by Munkris. So these books they're both called Advanced Calculus, the book by Edwards and Buck. The book by Edwards is pretty good. It's relatively affordable. It's a Dover paperback, and you can get it for about $20. The other books are pretty unaffordable, to be honest. The Buck book it's either very expensive or it's out of print, but the Buck book is really amazing, in my opinion. Spivak's book, I think, is out of print. I also heard some not so great things about it in terms of typos or mathematical errors. I'm not really sure. And the book by Munkris is very good, but I think it's also out of print. So the book by Spivak is called Calculus on Manifolds. And the book by Munkris is called Analysis on Manifolds. And these books definitely require familiarity with linear algebra. The Edwards book definitely requires linear algebra. Spivak and Munkris definitely. And they work in Rn, okay? And they talk about manifolds, which are like a generalization of surfaces. So this is roughly in order of difficulty, roughly speaking, but they all have their purpose, and my favorite of all of these is probably the book by Buck and the book by Munkris. The book by Edwards is pretty good, but there are some things about it that I don't like. And I don't really like the book by Colley because I think it's confusing. And I think Marsden and Tromba, compared to Colley, is just a better book. The explanations are more thorough and they're clearer. And then the Stewart and Briggs and Larson books are like, mainly for engineering students or computer science. Okay, so this also goes roughly in order of theory-based. The latter ones are much more heavy on the theory and have less computational examples. So I'll probably, in the videos that I make, will probably follow some combination of these books, probably not the Spivak book. I have never really read the Spivak book thoroughly, but the other books. Okay, and so the overview is to talk about differentiable functions and to talk about basically all the topics that are in the Stewart and Briggs and Larson book. So derivatives, partial derivatives, the multivariable calculus chain rule, the gradient, and things like that, the tangent plane. And then, but discuss it more using linear algebra and with more, theorems and proofs and that kind of thing, and less just kind of hand-wavy explanation. And I'm going to assume that if you're watching this, if you want to understand it, that you need to know the linear algebra pretty thoroughly, and then the integration theory. Yeah, looking back, these books, the Stewart and Briggs and Larson, really sweep a lot of things under the rug. And the other books do a much more thorough job of explaining the theory behind what's going on. Okay, so that's the overview of the series of lectures that I plan to give. Thanks for watching.